Welcome to today's deep dive. We're taking you through a stack of architectural markdown files and protocols today that map out something called the Caris Stack. And with my background in developer marketing and your years in software architecture, I think we're both pretty excited about this one.
Oh, absolutely. Because if you're building software today, especially on your own, you definitely know the solo dev's nightmare.
Yeah, the absolute friction of shipping unguided AI code.
Right. I mean, AI is this massive double-edged sword. It optimizes for these immediate requests, so you feel like you're moving incredibly fast.
But then you hit that paywall of death.
Exactly. You get trapped in this infinite loop of AI drift. The recommendations literally never end, and eventually your code base just completely collapses under real-world complexity.
Which is exactly why we wanted to break this down for you. This deep dive is essentially the ultimate guide to AI-assisted software engineering. And the creator behind this stack, Brandon Caris, he has a really unique background.
He really does. He's based out in Hawaii, and he actually didn't come from a traditional computer science background at all. He spent over 20 years as a registered nurse and an executive healthcare consultant.
Right. He authored those tablet computing nursing workflows in the insurance sector.
Yeah, and in healthcare, you don't just trust people to follow life-saving rules, you enforce them mathematically. So he took those rigid clinical algorithms and translated them directly into software governance.
So it's basically DevSecOps for solo developers. It lets one person build and scale like a full 5-person engineering pod without taking on all that crushing technical debt.
And a big part of how it accomplishes that is through something called tiered complexity routing.
Oh, I love this part. It completely saves your developer velocity for the simple stuff, but totally locks down high-risk architecture.
Right, so it calculates the cyclomatic complexity of a task.
Yeah.
If it's a low-complexity task, say it scores under a 5, the AI can just self-certify and move on.
Move fast, right?
Exactly. But if it's high complexity or it touches critical database files, the system mathematically forces a human review. It triggers this mandatory stop-and-think pre-flight audit.
Where the AI actually has to act like a senior architect and prove its architectural alignment before it writes a single line of production code.
Right, and to help with that, the system strips out all the bloated code using an AST-aware semantic bundler. It only gives the AI the exact semantic logic it needs.
Which is probably the best LLM code hallucination fix I've seen in a while.
For sure. And looking at the architecture itself, they enforce what they call the iron law of TDD.
Right, test-driven development, meaning absolutely zero production code without a failing test first.
But building software requires a messy phase, right? You need to make a mess to be creative.
You definitely do.
So they have this spike protocol. You can make a totally legal mess using specific extensions, like .proto files.
It builds a walled garden for that mess, because your CI/CD pipeline has hard gates that physically block those messy files from ever merging into production.
And when things do break in the real world, the stack assumes failure with the horror path defense.
It's called the horror path because we've all lived the horror of a database dropping at 2 a.m. on a Sunday.
Precisely. It's not enough to fail gracefully. The system requires active recovery mechanisms like circuit breakers, and they apply that exact same strictness to data performance.
Yeah, they enforce a keyset pagination API, so no more linear offset scans slowing everything down.
Right. It forces OLOG and database performance right from the start. Your query takes the exact same amount of time whether you have 1,000 users or 1,000,000.
It really just replaces developer trust with physical mathematical enforcement. It stops AI code rot before it even starts.
Letting you actually leverage AI speed without sacrificing your architecture.
It's completely reframed how I think about tooling. And it leaves you with an interesting thought to mull over. If an artificial intelligence requires a strictly enforced system constitution to prevent it from writing messy, unmaintainable code.
What does that say about how human developers have been operating all these years without one?